Hi guys, my name is Tanya, and today I'd like to talk to you about virtual reality and the promising future of its use in the treatment of neurological disorders and diseases. So, what is virtual reality exactly? Virtual reality is a computer generated 3D simulation environment which can be explored and interacted with by a person in a seemingly real or physical way. This is done through the use of specialized equipment, allowing the participant to become part of the virtual world. Okay, but what about virtual reality makes it so important? Well, while the participant is immersed within this environment, they are able to manipulate objects within their virtual surroundings or perform a series of actions, sometimes in ways not possible in the real world. When I first played virtual reality, I fell 80 stories from a non existent building, watched a comet whiz by from a platform in space, and became besties with a miniature goblin whom I've aptly named Gobbles. All jokes aside, this stuff is mind blowing and incredibly realistic. We've all seen the videos of the users running face first into the walls, right? This is because the current technology is finally advanced enough to be able to trick the user's brain into accepting their virtual surroundings as their real environment. This is what makes the experience feel so immersive. And while it may result in a hilarious collection of YouTube videos, this is also exactly what makes its application so promising. What's really special about virtual reality, and what I'd really like to focus on today, is the longer term implications of what all of this means for the future of the treatment of neurological disorders and diseases. Studies have shown that increased levels of environmental interaction result in a more highly developed and more efficient brain. Brain changes attributed to this increased interaction include more prolific connections between cortical neurons, increased activity in the glial cells, and a higher metabolic rate within the cerebral cortex. Now, conventional therapies in the treatment of neurological disorders, such as physiotherapy and speech therapy, also include increased levels of interaction. However, it is the compelling experience and immersive nature of current VR technology that make it such a powerful means of increasing levels of environmental interaction. Furthermore, interaction with a VR environment can even be made contingent upon whatever motor capacity or sensory impairments the patient has. This makes the technology uniquely well suited to this type of therapeutic function. Scientists are already deeply involved in VR studies surrounding the treatment of stroke, dementia, and even Parkinson's, and they're already seeing promising results in the progressive lucidity of their patients. What's more is that basing cybertherapy approaches on the theoretical understanding of the brain has the unique and exciting potential to provide a feedback loop for direct validation of brain theory in the clinic. So, whereas the technology behind all of the VR games on everyone's wish list right now is in itself incredible and may all seem like fun and games on the surface, or a really great way to avoid your relatives over the holidays, the potential future of virtual reality is bright and only just beginning to be tapped. When we look at the current and future applications of VR beyond the living room, we can see it's apt to be the next great leap in our understanding of neuroscience and the brain.